This review is for Unit 6, Similarity. We'll be doing this in several short videos. This is video 1, covering the first page of questions 1 through 8, proving triangles congruent, choosing criteria that apply. Okay. Determine whether each pair of triangles are similar. In terms of being similar, we have 4 choices: angle, angle, side, 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 angle, side, or not possible. Not possible being if I don't have enough information. If we say it's true, if we add anything to our diagram, we're going to go ahead and add additional reasoning. The 2 biggest reasonings, again, remember, are reflexive property if they share a side, vertical angles if the triangles touch, and then the third one, which happens occasionally, are our parallel line angle types corresponding alternate interior, alternate exterior as we're going through. So, question number 1, let's take a look. Right off the bat, I'm given 3 side lines, which makes me think side, side, side may be my case. We have to go ahead and prove that the sides are not congruent, but in fact proportional. Let's take a look at that. If these are proportional, we would be able to take the smallest side, compare it to the smallest side. 20 over the median side, and the hypotenuse over the hypotenuse, they all reduce down to the same number. Do they? All reduce down to 2 over 9, which means that yes, triangle BCD is in fact congruent, not congruent, similar. Triangle LKM by side, side, side similarity. We didn't add anything to our diagram. We just set the sides in proportion, so there was no reasoning used in number 1. Number 2, right off the bat, we see that we're given an angle measure, and that's about it. However, we should note that these triangles are sharing a vertex. That lets me know that these angles are in fact vertical angles. Now that I have 2 angles, they are congruent. That lets me know that this is similarity, and that triangle SRQ is similar to triangle SMN. SRQ, SMN, angle, angle, similarity. Next question, problem number 3. I am given 2 side lengths, and once again we have a vertex that is shared, so I know that these are vertical angles. So now that I have a side between the other side, what I have to check is that the sides are proportional. 3 over 4 should reduce down to the same number as 89 over 11. Does it? No, it does not. 10 over 1 does not equal 89 over 11. So this is an example of not possible. These triangles are not congruent. Looks like they may be, however, they're not. Question number 4. Once again, we're presented with a similar scenario. We have a shared vertex, which means that these are going to be angles, and we have 2 sides on either side of the angle, so it's looking like side, angle, side, triangle similarity. We have the congruent angle, so we need to set 28 over 77 should reduce down to the same number as 56 over 154. Do they? Yes, they do. They both reduce down to 4 over 11, meaning that we have triangles being similar by side, angle, similarity, and the 2 triangles that are congruent, similar are triangle UKL. Once again, we added vertical angles onto it. So there we are. Question number 5. Right off the bat, we should again notice we have a shared vertex, meaning that we have a set of congruent angles here by vertical angles. What also we should note is the fact that we see these little symbols, which in fact mean we have parallel lines. So 2 parallel lines cut by a transversal means that we have congruent angle types. In this case, we should note where we use this line as our transversal between the 2. That means that this angle, which I already blew, this angle is in fact congruent to this angle by what angle type? Alternate interior angles. I sketched along here the side. There's my top parallel, there's my bottom parallel line, and there's my transversal. Yes, they're in fact alternate interior angles. We could also set up another set of alternate interior angles here if we wish. So that's all we need to show they're similar. Angle, angle similarity. Triangle UVC is similar to triangle UVW. question 6. Looking at we see that we have 50 is in fact congruent to this 58-degree angle, and we have two sets of sides on either side of my angle, so it's an included angle, so I'm thinking side angle side. So the only thing to show here is that the side lengths are in proportion. 21 to 28, 27 to 36. 21 over 28. Does it reduce down to the same number? Yes, it does. 3 over 4, meaning that side lengths are in proportion, meaning that we are congruent by an angle in the middle, and two proportional sides, meaning we are similar via side angle side similarity. We did not add any official things to our diagram, so I won't have any reasonings. However, we can now write the similarity statement of triangle DCB is similar to triangle FGH. Next problem, number 7. We see that we are given two angles. However, we only have one congruent angle here. 74 is congruent to 74. 44 does not match up with 62. However, I should be able to figure out my missing angle in both triangles via the triangle sum property, which states that all three angles in a triangle must add up to 180 degrees. So for my smaller triangle, angle N plus angle L plus angle M should equal 180. So by substitution, angle N plus 44 plus 74 should be equal, meaning that angle N is also equal to. We have two congruent angles, meaning similar via A. And triangle QRS is similar to triangle LMN. Last question. Note again that we should parallel lines being cut by a transversal. Therefore, we have lots of different other angle types. In this case, we're going to go ahead and start off with corresponding angles. Angle U and angle D are corresponding. If these are parallel lines and this is my transversal, as I've sketched over here, we know they are congruent. So corresponding angles gives us one congruent angle type. We could set up another corresponding angle over here. I'm going to focus on angle W, as angle W appears in both triangles, meaning that it's congruent to itself via the reflexive property. Usually reflexive we use for triangle congruencies for sides that touched or shared, two triangles that shared a side. We can also do it for reflexive angles. This angle is common to both, so it is congruent to itself, meaning we have two congruent angles, meaning we have angle-angle similarity, meaning that triangle WVU is similar to WCI, angle-angle similarity. First page of the exam will be on these angles, recognizing these triangle similarity theorems, just like the last exam was triangle congruence theorems. Be prepared to pick out these three along with the not possible. Number 3, not enough information. Excellent. Thanks.